Right, RI 2021, question number 1. If A equals to 9 minus 99 plus 999 minus 99999 and so on and so forth until you have 2021 nines, find the sum of the digits of the A of the result. Okay, so in this case you can have two ways. One approach is by using negative number. 9 minus 99 is negative 90, as well as this 999 minus 999 is negative 9000, and so on and so forth. Okay, then you plus 9999. Second way is to do it in positive ways. So instead of pairing the first and the second, I'll pair the second and the third, and I'll have 900. I'll pair the fourth and the fifth, I will have 90,000. Same thing all the way until the last one. I have 9 with 2020 zeros at the back. Okay, when I add every number together, this one I will have 909090, repeat until all together 2021 digits. Okay, meaning I have 1011 digits of 9. Yeah, because I have 2021 digits of 9 and zeros alternate. That means for 9 I have 1011, and for the 0 I have 1010. But the sum of 1010 0 is just 0, so I'll just take this one. 9 times 1011. Okay, question number 2. If the positive odd integers are arranged in rows of 16 as shown below, everything is odd numbers, so 1, 3, 5, 7, 9, 11, 13, and so on and so forth until 31. And the number 2021 will appear in the mth row and nth column. Find m times n. Okay, let me give you an example for number 81. Okay, it appears in the third row and the 9th column. Alright, so how about 2021? For this type of question, you always need to find a pattern. There's always a pattern. So for example, you look at the first number of each row. Okay, everything you need to plus 32 plus 32. Okay, meaning it will be a group of 32. I divide the number given by 32. I will have 63 remainder 5. 63 means the number of rows, and remainder 5 is 5 numbers after that. Okay, in this case, since we only have odd numbers, so the 5 here will be the number 5 over here, which is the third column. Okay, the number of rows is not 63 because we have 63 rows and then an extra of this remainder 5, so that means it will be 64th row. Okay, so they ask us to find what is m times n. So m times n will be 192. Okay, if you want to know how to divide 2021 by 32, just to estimation, 32 times 100 is 3200. That means it will be slightly more than half of it. So 50 times 32 is this. You slowly add all the numbers, then you have 63 times 32 is 2016. Okay, so that's why it's 63 remainder 5. Okay, question 3. A number A have the same factors as 2021, which prime factorization is 43 times 47. Number of factors of A square is perfect square. Which of the following may be the number A? Okay, in this question, most important thing is this one. A must be in this form. A square must have a perfect square number of factors. What does it mean? Okay, let's take a look at 2021. Is 43 times 47. Remember, if the numbers are in this form of prime factorization, 2 power A times 3 power B times 5 power C, number of factors of this number will be A plus 1 times B plus 1 times C plus 1. Okay, so it means for 2021, 43 power 1 and 47 power 1, the number of factors will be 2 times 2. Okay, and then 2021 square is 43 square times 47 square. The number of factors of this number will be 3 times 3. So 3 times 3 is 9, so 9 is a perfect square. So that what it means by a square has a perfect square number of factors. Okay, why is this important? Because, for example, this 1331 for option A is also have 4 factors, okay, namely 1, 11, 121 and 1331. But if I square the number, it will be 11 to the power of 6. Number of factors for this will be 6 plus 1 by itself, so it's 7. So 7 is not a perfect square. Okay, so even though the number of factors of A is the same, but the number of factors for A square is not perfect square. So A is out. Okay, then you can check B, C and D. For B and C is a bit difficult to find the factors. 783 is the easiest because 783 is a multiple of 3. 783 multiple of 3, so you divide by 3, divide by 3 again until you have 3 to the power of 3 times 29. Okay? Then this form is not even equals to this form, so I can safely remove this as an option. Then these two number, you will need Howard to do it. So at most what we can do is we use the rule of divisibility by 7, 11 and 13. So for these three numbers, because everything is a factor of 1001, okay, you can check the multiple of 7, 11 and 13 in groups of 3, meaning you can split this into group of 3. This is odd group, this is even group. Okay, odd minus even group must be multiple of 7, 11 or 13, but 853 is not multiple of any of these three. So that means we can conclude that this number is not a multiple of 7, 11 or 13. Okay, then we can slowly check. Okay, for I, normally they will require you to check, divide and multiply with some random numbers, very difficult numbers. Okay, so you have to do it. So in this case, you see what I did here? I divide this by 17. I found out that it is not multiple of 17. When divided by 19, it is multiple of 19. Okay, so 6, 8, 5, 9 divided by 19, I have 361. And then if you memorize your perfect square numbers, you realize that 361 is also 19 square. So that means this number will be 19 to the power of 3. Okay, and this is not the same as 43 and 47, right? So I can rule out this one as well. And then for 1073, another round of hard work, keep trying, divide by 17, 19, 23, and 29. Okay, only when you have reached 29, then you can get 37. Okay, so this is the same form as 47 times 43, right? So this will be the answer. Okay. So same thing, if let's say 1073 is also not in the same form, do not hesitate to answer E. Okay, because normally RI there will be a lot of answer which is an E. Okay, but you have to check carefully. If let's say everything is done carefully and you still cannot find the answer from A to D, okay, do not hesitate to answer E. Okay, but for this question we have the answer, which is a C. Alright, question number 4. There are two diagrams, or there are only one diagram. Okay, the area of this small one is S. How many statements of these 4 are true? Okay, I duplicate the diagram so it will be easier for us to see. ABC is 2S. ABC is this big. Okay, so for this question, probably I'll start from the below. Okay, let's talk about EFG first. Okay, EFG is similar to this shape. right? Or I may say congruent to this shape. So this shape is half of the S, so that means EFG will be half S. So the first statement is wrong. CDF is this part. Again, this is congruent to this, so CDF must be half S. So this is correct. Okay, then CDE is this part. This is double of half S, right? So it will be S. So this is wrong. And then ABC, this is double of this. Okay, you can see here. So it's 2S is correct. Okay, so that means two statements are true. The answer is B. Okay, for question 5, circles of radius 1, 1.5, 2, 2.5, and 3 cm are drawn with the vertex of a pentagon. Okay, all these are regular pentagon. Find the total of area of shaded part in cm squared. Okay, for pentagon, sum of interior angles, remember the formula n minus 2 times 180, where n is the number of sides. So for pentagon, number of sides is 5, so 5 minus 2 times 180 will be 540. That means each of the angles of pentagon is 108. So here is 108, here is 108, even this small one is also 108. Okay, then that means to find the area of shaded, I can just simply take 108 over 360 times the area of the circle of each individual circles. Okay, for example, this one is 3 over 10. Oh, 108 over 360 is 3 over 10. So it's 310 times pi times radius times radius. It's also 310 times pi times radius times radius. Then I realize that everything in the same pattern, so I can combine everything into 3 pi times radius square, radius square, radius square, and so on and so forth. Okay, I can simplify these two first. Okay, then I get 33 over 35. And then for 1 square, 1.5 square, 2 square, 2.5 square, and 3 square, you can calculate manually. Okay, for this 1.5 square and 2.5 square, there's a trick to find this answer in an easier way. Okay, when you see something 0.5 and then you want to find the square of it, okay, it's always 0.25, and then the front number will be x times x plus 1. Okay, so for example, 6.5 square, it will be 0.25, and then the front number will be 6 times 7. Okay, 9.5 will be 0.25, 9 times 10. Okay, so that's how you count multiple of 15. Oh, I say something that ends with a 5. Okay, then after you count everything, you add manually, you will have 22.5 times this number, because it's quite difficult to multiply with decimals. I'm going to make this into 45 over 2, and then I cancel this and this. I'll have 33 times 9 over 14. Oh, we don't have to change to mixed number. This is the option B. Alright, question 6. Adrian and Brian are running at constant speed around a circular track of length 400 meters. Adrian's speed is 2/3 of that. Brian's will be 3 units, while Adrian will be 2 units for the speed. If given the same amount of time, okay, the ratio of the distance covered by A to B will be also the same ratio, which is 2:3. Okay, they start running from the same point at the same time. So for example, they start from here, and then Adrian go this direction and Brian go this direction. After 4 minutes, they have met 4 times. Okay, so in 4 minutes, they have met 4 times. So let's imagine the track will be in 5 parts. Okay, because the distance that covered by both Adrian and Brian in units will be 5, because Adrian will cover 2 and Brian will cover 3. So when they meet, right, the distance covered will be something like this. Adrian will cover 2 units and Brian will cover 3 units. Okay, the same thing. The second meeting will be when Adrian have traveled 2 units. Okay, so in short, Adrian will run this way, another 2 unit, another 2 unit when they meet 4 times. Okay, realize when they meet for the 5th time, right, it will be the full circle. So probably you need that to make the calculation easier. So when they meet for the 5 times, it will be 2 of the circumference. Okay, so distance traveled by Adrian, okay, is 4 out of 5 of the 2 circumference. Okay, so since we know that one circumference is 400, 2 circumference will be 800. That if they meet 5 times, but they only meet 4 times, so I'll just take 4/5 of that distance, which is 640. Okay, or you can just divide this by 5 to get 160 for each, then just count accordingly. Okay, so since they travel, the distance is 4 minutes, the speed for Adrian will be 640 divided by 4, that will be 160. Then for Brian, it is 3/2 times of Adrian, so that's how I get 240. Read the question again. They ask you to find the difference between Brian and Adrian's speed, but in meter per second. Okay, so what we have here will be in meter per minute. So the difference is 80 meter per minute. I need to convert this into meter per second. Okay, how? 80 meter per minute means 1 minute in 1 minute will travel 80 meters. That means 60 seconds is 80 meters. That means 1 second will give you 80 divided by 60, which is 4/3 meter. Okay, that's how I get 4/3 meter per second, and that is D. Okay. For question 7, a number is removed from 6 consecutive numbers. For example, I have 3, 4, 5, 6, 7, 8. I remove one of them. Okay. Then when I add the remaining, it will give me 662. What is the position of the number that was removed when the 6 numbers are written in increasing order? Means if this is the case, the answer will be 3rd position. Okay, so let's take a look on how to do the question. Remember, when you have a consecutive numbers, what we can use to find any of the numbers will be the average, okay, if it's given the total. So now we are given the total of 5 of the remaining, okay, 662. Okay, even though we cannot find what is the exact number, we can at least have a clue on what is the range of the number. Okay, so I'll divide this by 5 to get the range of the number. It will be 132 remainder 2, meaning it will be in the range of 132. So you can write a 5 slot. Okay, the middle number will be 132, this 131, 133, 134, and 130, because it must be 6 consecutive integers. But when you do this, the total will only be 660. Okay, so that's why, since you have 662, 2 must be added to the number. So I can choose to add this number by 2. Okay, but in this case, I will have 2 missing number, which is not what we want. Okay, so the only way to make only one number is taken out is by plussing 1 to these 2 numbers. Okay, so that we have everything is still consecutive with 133 missing. Okay, so the number that they remove is actually 133. Okay, as we have over here. So 133 is removed. What position is the 133? So it's the 1st position, 2nd position, 3rd position, and 133 will be the 4th position. Okay, so quite simple. The main concept they have to remember is the average. Okay, question A. The ratio of the number of marbles in the 3 bags A, B, C is 3:1:5. 10% of the marbles in bag C are removed and transferred to bag B. 1/3 of the remaining marbles in C are removed again and then transferred to bag A. Now the total number of marbles in bag A and bag B is 2400. Find the number of marbles in bag C in the end. So when I see this question, I always change this percentage into a fraction first. Okay, and then we have 1/3 here. Okay, so when I see this 1/10, right, of something, the something, which is in this case bag C, will be a multiple of 10. Okay, when it's 1/10, it's multiple of 10. When it's 1/5, it's multiple of 5. When it's 1/3, it's multiple of 3. Okay, always keep that in mind. So when I see this ratio, originally is 3:1:5, and C is not in multiple of 10 yet. So that's why I multiply this by 2. That means everything I have to times 2. Then the ratio becomes 6:2:10. And then I take out 1/10, which is 1 unit, and transfer it to B. Okay, then the ratio after the transfer will be 6:3:9. And then they say they transfer 1/3 from this C to A. Okay, same thing. 1/3 means this number must be a multiple of 3. Okay, in this case, 9 is multiple of 3, so I don't have to update the fraction or the ratio. Okay, so I just leave it as it is. If it's not multiple of 3, I have to multiply by 3 again to make it multiple of 3. Okay, so 9, 1/3 of 9 is 3, so I minus 3 here and I put 3 to bag A. Okay, so the ratio now become 9:3:6. Okay, if you want to simplify this form, can. Okay, 3:1:2. Okay, but the weakness of this updating the ratio again is if they ask you to find number of A and B and C in the end, okay, you cannot find it straight away because the number that we use is originally from here. So if we update this one, this can only be used for in the end. Okay, so that's why I don't do it over here. So I'll just take A and B is 2400. That means A and B is 2400. 12 unit is 2400. That means 1 unit. Okay, if you want to find 1 unit, is 200. But in this case, since I need to find C, C is 6 unit, which is half of this 12. I just need to divide by 2. Okay, so the answer is 1200. Okay, for question number 9, the digit 972, 521, and 210 are in decreasing order, where the 279, 522, 212 are not. How many 3-digit even numbers have their digit in decreasing order? So when I look at this question, I don't think I can use anything other than a listing method together with a combination and permutation. Yeah, so when we do a listing, I don't mean that we have to list everything out. You have to combine it with sum of combination and permutation. So in this case, I start from 100 place to be 9. Okay, so when my 100 place is 9, for my 10th place, I can have 8 options. But when I see the 8 options, I do not think that everybody have a same amount of choices. So that's why I try to list out in more details. If I have 9, 8, I will have 4 choices at the back, namely 2, 4, 6, and 0. Okay, because they only want us to find the even numbers. Okay, so the behind part is 0, 2, 4, 6. So I have 4. Same thing for 9, 7. I have also 4. 9, 6, I have 3. 9, 5, I have 3. 9, 4, if you want to list out, you have 2. 9, 3, 2. 9, 2 is 1. 9, 1 is 1. 9, 0, we couldn't have anything. Okay, because the number cannot be the same. It must be in decreasing order. So the total for 9 is 20. Okay, the next one is 8 in the 100 place. So when 8 is 100 place, the situation will be the same as this part. Okay, where my 10th digit will be 7, 6, 5, 4, 3, 2, 1. So I'll just take the 20 minus this 4. Okay, to find the 8. So it's 16. Okay, I'll do something for 6, 7 and 6 and 5, 3, 2, 1. So I minus this 4 again to get 12. I minus this 3 to get 9. I minus the 3 again to get 6. Okay, then I minus 2, I minus 2, and I minus 1. Okay, so in total, now we have 70. Okay, so in short, I'll just do a listing for 9. Okay, then we do a smart listing for 9, and then we find what is the pattern for 8, and then we find the pattern for 7, 6, 5, 4, 3, 2, 1. Okay, since there are only like 9 cases, we just do it manually to get the answer 70. Okay, question number 10. 9 of consecutive whole numbers will be put into this such that the sum of the 3 numbers along the line is the same. So that means this is the same sum as this, same sum as this, and this. Okay, then the question said 21 is the largest of the whole numbers. What is the least possible sum of the numbers along the line? Okay, so there are a few requirements here. The 9 numbers must be consecutive, and the largest number must be 21. So the numbers are quite big, so if I want to use all the big numbers, it might be confusing for our brain, okay, at least for mine. So in that case, I'm going to use a small number, okay, for example 1 to 9. Then I find out the position of each number first before I transfer it to a bigger number. Okay, so in this case, you can find it by putting the 1 here. Since the question wants me to find the smallest number, so the sum must be the smallest. So this number appear in everything, right? So that's why I put it as the smallest. So this is position number 1. Okay, then for the rest of this number, we know that from 1 to 9, the sum is 45, right? Okay, then if I minus number 1, we will have 44. So when we have 44, and we have 4 groups of the sum, okay, we have C1, 2, 3, and 4. So when C4, then we just need to immediately take 44 divided by 4 to get 11. That means the sum of the remaining 2 numbers will be 11. So it will be 2 and 9, 3 and 8, 4 and 7, and 5 and 6. Okay, pretty straightforward, right? Then from here, I'll just transfer the numbers. The biggest one is 2021 here. This will be 2021 minus 8, okay, which is 2013. Then this number will be the number after that. Okay, then the answer that I get is 6048. After that, I cannot see anything in the options, right? Then I have to check back if my answer is correct. Okay, maybe our concept at the start here is wrong. So I'm going to check again. If I put 9 here, what is the sum? So 1 plus 2 plus 3 until 8. It will be 36. 36. There we have 4. We have 9. Okay, so 9 means it can be 1 and 8, 2 and 7, 3 and 6, and 4 and 5. Okay, when I have this one, the number 2021 have to be here. This will be 2020, and this will be 2013. Okay, so when I add these 3, it will be 6,058, 54. Okay, I'll have the number here in the options, but that will be larger than my 6048. Okay, so that's why I choose to pick the answer as E. Okay, so when you have your answer is not in the option, maybe you can try to doubt yourself once. Okay, check if there's a counter example. If there's not, then you can safely assume the answer is E. Okay. Question number 11. The value of 1 over 43 plus 1 over 43 plus 86 plus 1 over 43 plus 86 plus 129 all the way until 1 over 43 plus 86 plus blah 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 until 2091 is. Okay, so in this case, I will simplify the problem. Since everything is multiple of 43, right? I can simplify this into 1 over 43 times bracket 1, or I can put 1 over 1. This is 1 over 1 plus 2. This is 1 over 1 plus 2 plus 3. Okay, all the way until 1 over 1 plus 2 plus 3 until 47. Okay, for this part, 1 until 47 is a consecutive number, so I just take 47 times 48 divided by 2. Okay, if I flip over, because I need to find 1 over all this sum, so it will be 2 over 47 times 48. So that's how I can jump to this conclusion that this value will be equal to this value. Okay, since I have 2 for everything again, I just take out everything. Then remember, for 1 over 1 times 2, I can split them into two fractions. It's a partial fraction concept. It will be 1 over 1 minus 1 over 2. If it's 1 over 1 times 3, I can also split into 1 over 1 minus 1 over 3. But in this case, I have to times half. Okay, because 1 over 1 minus 1 over 3 is 2 over 3. Okay, so in order to make it to be 1 over 3 again, I have to times half. Okay, so same thing with 1 over 1 times 4. I can put into 1 over 1 minus 1 over 4 times 1/3. So over here we can conclude that 1 over A times B can split that into 1 over A minus 1 over B, but I have to multiply with 1 over the difference. Okay, so since all the difference here is 1, okay, I can safely split them into the fractions just by looking at their denominator. 1 over 1 minus 1 over 2, 1 over 2 minus 1 over 3, and so on and so forth, until the last part is 1 over 47 minus 1 over 48. Okay, then we realize that this is going to be 0. Everything else in the middle is going to be 0. So I just take the first one minus the last one, which is 47 times 48, and then multiply with the fraction 2 over 43 in the front. Okay, so this times this. We can actually simplify first, but I don't know why I didn't simplify. So multiply first, you can simplify again later. Okay, the answer is going to be the same, 47 over 1032. That will be A. Okay, if this question I have a different answer from this 4, I'll be quite worried. Okay, but fortunately for this one, I have the same answer as A. Okay. Question number 12. S equals to 1 power A plus 2 to the power B plus 3 power C plus 4 power D plus 5 power E. A, B, C, D, E are positive integers, and I only know that D is odd. Which one of the following value for B will ensure that the last digit of S is not 1? Okay, there are a lot of concepts that they are testing here. But the very important concept here is the power. Okay, when I see 1 to the power of A, the last digit, okay, the other concept that they're asking you to know is the last digit. Okay, 1 to the power of A is always have a last digit 1, or in fact it's just 1. Okay, for 5 to the power of E, the last digit is always 5. Okay, because 5 times 5 is 25, 25 times 5, another 5 as the last digit. Okay, it doesn't matter how many times you multiply, you will get a 5. Okay, does it work the same for 4, 2, and 3? Okay, in general, at most, you will need 4 terms to repeat the pattern. There's always a pattern. So for example, 8 power 1 is 8, 8 to the power 2 is 64. Okay, 8 power 3 is 512. So you see this one, 8 times 8, you get 4. 4 times 8, you have 32. So just take the last digit. 8 times 2, the last digit will be 6. Okay, then 6, I times 8 again. The last digit is 8, 48. Right, so the pattern repeat every 4, if you can see here. Okay, for the last digit, the pattern repeat every 4 at most. Okay, sometimes it can be repeat every 2, some even repeat every term like 1 and 5. So we're going to find out for 3, 5, and 4. Okay, for 4, since I know 4 is to the power of odd numbers, let's find for 4. 4, 1 is 4, 4, 2 is 16, 4, 3 is 64, so end up with 4 again. Okay, so I find a pattern that repeats every 2, 4, 6, 4, 6. So just nice, if 4 to the power of odd numbers, it will give me the last digit 4. Okay. Then we realize that for 1, 4, and 5, if we add the last digit together, it will give us the last digit 0, meaning that this 3 will contribute to nothing, okay, to the answer, because this 3 will always have the last digit of 0, which means that I just need to consider 2 to the power of b and 3 to the power of c for the answer. Okay, just now we talked about this. The pattern will repeat every 4, so just do it for 2 and 3. Okay, for 2 is 2, 4, 8, 6, 2. For 3 is 3, 9, 7, 1, and then back to 3 again. Okay, so the question is asking us to find out the value of b so that it will ensure that the last digit of s is not 1. Okay, so let's check for 2 power b. This last digit, can I make sure that it's not 1? I cannot, because 2 you might add with 9 to get a 1. Same thing with this 4, you can add with a 7 to get a 1. 8, you also can add with 3 to get a 1. 6, you must add 5 to get a 1, but there's no 5 for power 3, so I need this kind of b. Okay, so for example, b equals to 4, this will not give me 1 for sure, 100%. Okay, so this is kind of the number that we want. So since the pattern repeat every 4, this number is always multiple of 4. Okay, every multiple of 4 will ensure that the last digit is not 1. Okay, so that means we just need to find the multiple of 4 in the options. So we have our 24. Okay, so for 74, since 74 divided by 4 is 18 divided by 2. So this remainder 2 will give us 4. So 4 will not ensure that the last digit is not 1. Okay, because there's a 25% chance of it being 1. Okay, so in this case, we need to find out the answer that is multiple of 4. So that's why our answer for this question is A. Okay, for question 13, Alicia built a structure with small cubes of the same size. The top view of the structure is a square. The front view and one side of the view are the same as shown below. Okay, it's the black color. Alicia built this structure with the maximum number of cubes possible, so that if she add one more cube to the structure, it will change the views, okay, in any angles. So how many face of cube does she have to paint if she want to paint the entire structure? Okay, face means this side consider as one face, this one 2, this one 3. Okay, first thing first, remember for this type of 3D shapes, the front view and the back view is always the same. The left view and the right view is always the same. So I cannot have anything on this side. Okay, because if I add one more, it will change the view. Okay, so I cannot have anything over there. Same thing, I cannot have everything like over here. That means the maximum for this structure to the back will be equivalent to this 3. Okay, these 2, the back must have also 2 because I cannot have anything like at this area. So that means it can only have this 4 by 4, 5 by 5, 6 by 6. Okay, that's the maximum number of cubes possible. Then we realize that this is the front view. The back view will also be the same as this. Okay, probably it's just the mirror image. Then, since we know that this is the maximum structure, this is for our left side, our right side will also be the same. Okay, in this structure. So, we can find the number of sides or faces that we have to paint on the front, back, left, and right. Okay, front is 21, left is 21, that means the back is also 21, the right is also 21. Okay, so the bottom and top is also always the same. Okay, we see from the top is the same as we see from bottom. So since from the bottom here we have 6 by 6 is 36, that means from the top is also 36. Okay, so in this case you can have 21 times 4 and 36 times 2. Add up together, I will have 156 faces. Okay, so the answer is C. Oh, this is the drawing if you need a visualization on the previous question. So you see here for the side view, also the same 1, 2, 3, 4, 5, 6. Okay, for the top view also the same. It will be 1 plus 3, which is 4, plus 5 is 9, plus 7 is 16. Okay, so we have 36. If I add anything here, right, it will change the view. Okay, so this is the maximum that I can have. Okay, for question number 14, a palindromic number is the one that when you read from the back and from the front are the same. For example, it's 272, 979. Okay, all palindromic number are increasing order starting from 11, 11 are written in a row like this. Okay, so 99, 101, 111, 121. So in increasing order, what is the digit in the 661st position? Okay, so in this case, we have to use counting and listing. Okay, so for 2-digit palindrome, I have 9 of them, so that give us 18 digits. For 3-digit palindrome, okay, I will do it slowly. I start with 101, 111, 121, all the way to 191. I have 10 of them. I have 3 digits each, so it's 30 digits. And I have 9 of them. That means I will have 270 digits. This is still way below 661. So we're gonna do the same thing for 4-digit. 4-digit and 3-digit palindrome, if you realize they will have the same number of numbers. Okay, if there are 30 palindrome for this one, there will also be a 30 palindrome for this one. Okay, but in this case, we will have 40 digits for the first one. So 9 times 40 will be 360. Then we check if this is out of the range, but actually it's not. It only covers 648 digits. Okay, so 661 minus 648, I'll have another 13 digits to play with, so that will be our 5-digit palindrome. The smallest of 5-digit palindrome will be 10001, followed by 10101, and then 10201. So three palindrome number is enough to cover the 13. So just count manually. What is the 13th digit? Here it will be 2. So the answer for this question is E. So again, this is not in the option, so you might doubt yourself for the first time and check again if there's any miscalculation over here. Okay, but you are sure of yourself in the first try, you can just answer E. Okay, but for me, I will just second doubt myself. I'll check again if there's any mistake. Okay, if I check twice and there's no mistake and I still get the same answer, so I'll just put it as the answer. Okay, for 15, in Ivan's field, there are 4 trees forming the vertices of a square with the length of adjacent trees is 10 meters apart. Okay, Ivan asked 2 of his friends, Alex and Ben, for the suggestion to create a triangle enclosed using the 4 trees as a part of the fence. Okay, as you can see here, this is Alex's model and this is Ben's model. Okay, they didn't ask you which one is the most efficient. They just ask you what is the ratio of the area enclosed by Alex's model and enclosed by Ben's model. Okay, so in this case you have to find what is the Alex area and Ben's area, okay, in units or in comparison. Okay, since there are 4 trees, we will use these 4 as a base of our ratio. Okay, so in Alex's model, you can easily see that we connect this. Yes, we can connect this as well. So I will have 4 different equal parts. Okay, 4 equal parts, that means if this area is 2, total area is 4. Okay, then for Ben's model, if I cut the same way, okay, only these 4 are the same. This one is not. I'm not too sure if this is half. Okay, so I cannot really find the ratio. I cannot say that it is 4 is to 4.5. Okay, let's find out in more details. If I have this, that means it will be the same as 1/4. Yeah, so this is the same as this. So I'll probably just cut it into smaller pieces. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Here is 9, and over here is also cut into the same one. And I have 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. So that means our 4 is to 4.5. Guess is correct, but we cannot do it at the start. Okay, so we have to make sure that we prove that it is correct. So it will be 8 is to 9. So the answer for this question is C. Okay, for question 16, for the whole number m factorial is 1 times 2 times 3 times 4 all the way until m. So for example, 6 factorial is 1 times 2 times 3 times 4 times 5 times 6. What is the remainder when 1 factorial times 2 factorial plus 2 factorial times 3 factorial plus 3 factorial times 4 factorial plus all the way until 2020 factorial times 2021 factorials? Okay, when you see this question, I need to find the remainder when it is divided by 18. So we know that 18 is 2 times 3 square. Okay, so if we observe carefully, when I have 3 factorial and 4 factorial, I will have 1, 2 here, and I have 2 of the 3 here. Okay, meaning that this will be a multiple of 18. Means if this is divided by 18, my remainder is 0. Which means from this point onwards, okay, everything will have a factor 2 and 2 of factor 3. Okay, means the remainder will be 0. Okay, from here to here, remainder will be 0. That means we just need to check the first two terms on what is the remainder. Okay, 1 factorial times 2 factorial is 2. 2 factorial is 2. 3 factorial is 6, so it's 12. And then these two add together will give us 14. 14 divided by 18 is not divisible, so the remainder will just be 14. Okay, for question 17, find the last digit of 2021 cube minus 2020 cube plus 2019 cube minus 2018 cube and so on and so forth until you have 3 cube minus 2 cube plus 1 cube. Alright, for this question, they want us to find the last digit, so we just need to find the last digit. We don't need to find anything else. So in this case, I can simplify this into 1 cube minus 0 cube, which is 1. Okay, for this one and this one, last digit will be 9 and 2. Okay, so the last digit will be 7 for this group. And since everything in group of 2, right, I can just find the first 10 and then after that it will be repeated. Okay, so 7 cube minus 6 cube will give us negative 3. 5 cube minus 4 cube will give us 1. 3 cube minus 2 cube will give us negative 1. In total, the last digit for the group of 10 is 5. Okay, then you need to find how many groups of 10 are there. So from 2021 into 1 or 2021 to 2, there will be 2020 terms. So if I divide into group of 10, I will have 202 groups. Okay, so 202 multiplied by 5, I will have a last digit 0. Okay, this one we haven't counted the last term here. So last term here will give us 1. Okay, so that means for this whole thing, the last digit will be 1. Okay. Question 18. Player A and player B are competing in the table tennis games. Starting from a score 0-0, two competitors try to earn 1 point at a time. As long as the competitor don't reach the score 10-10, the games will end when the competitor reach 11. So this person watched the game and received a phone call when player A has 8 points and player B have 0 points. Okay, then after that you walk outside. When you come back, the player A won a game and the score is 11-8. Okay, so how many different ways could player A have reached the score 11-8 from the score 8-0? Okay, in this case, we need to consider the total points or total score that he missed out. Okay, so from 8-0 to 11-8, A will score 3 more and B scored 8 more. Okay, so total point is 11. But, okay, there's this but. The last point must be scored by A because A won the game. So total point before the match point, okay, is 10. Okay, that means it can be A, B, A, B, A, B, all the way, but the last one must be won by A. So that means we just need to consider the previous 10 points. Okay, for this case, remember about the permutation and combination where we choose 2 out of how many cases? Okay, so in this case, I have 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 points. These 10 points, I need to choose 2 of them to be A, okay, because A scored 3 in total. If we minus the match point, A was scored 2 out of 10. So we need to find 2 from the given 10. Okay, how many ways are there? 10 choose 2, meaning that 10 factorials divided by 8 factorials and 2 factorials. Okay, or you can do it as easy as this. Okay, write down the two numbers starting from 10 and then over 2 times 1. Okay, there will be 45 ways. Or you can also do the other way. Okay, instead of choose 2 out of 10 to be A, you can also choose 8 out of 10 to be B. Okay, so choose A out of 10 will be 10C8. Then it will give you the same thing. Okay, so 10 times 9 over 2 times 1, it will give us 45. Okay, for question 18, player A and player B are competing in the table tennis game, starting from 0-0. So as long as nobody reaches 10-10, the game ends when someone reaches 11 points. Okay, Samar watched the game and received a phone call when player A has scored 8 and B scored 0. Okay, he stepped outside to answer the phone call. When he come back, he saw the score is won by A by 11-8. Okay, so in how many ways that the gameplay can reach 11-8 from 8-10? Okay, so in this question, I need to know how many points scored by A and how many scored by B. Okay, A scored 3 and B scored 8. Okay, total points will be 11, but the last point must be scored by A because A won the game. So total points before the match points and after the 8-0 is 10. Okay, this 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, can be like A, B, A, B, 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 B. Okay, or it can also be B, 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 then A, B, A, B, B. Okay, in any way possible. So how many ways are there? Okay, in this case, as usual, there will be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, for the normal permutation and combination. Okay, we have 10 factorials ways because there will be 10 slots. Okay, but in this case, A is repeated 2 times and B is repeated 8 times. So that means after I multiply all this, I must divide by 8 factorial and 2 factorial. Okay, this is our 8 factorials. These 8 factorials can cancel off, and then it just means that you just take 10 times 9 over 2 times 1. Okay, this is the same as if you take 10C2. Okay, 10C2 means you choose 2 out of 10. So the formula will be this, okay? Or you can remember the main formula, 10 factorial over 8 factorial 2 factorial, because NCR will be n factorial over n minus r factorial times . Okay, question 19. 4 by 4 by 4 cube. Some faces of the large cube have been painted. If the number of small cubes that have paint on at least one of the faces is 37, how many faces of the large cube have been painted? So the answer for this question is at most 6 because the large cube have 6 faces. Okay, so we need to find the maximum or maybe the minimum number of faces that have been painted. Okay, in this question, let's say one of the faces have been painted. So how many faces are there? Okay, so this one face is painted. That means number of cubes that have the paint on at least one of the sides will be 16. Okay, if two sides, the maximum we can have is 32. Okay, we have 32. Then the third side, if we choose these two, okay, it will be this. Okay, this one we have already counted. That means we just need to count the 8 in the middle. So we have 40 cubes. 40 cubes is not in the question. Okay, question 1 asks 37. So we need to find another way. So instead of putting it on this side and this side, we immediately combine them together. Okay, so at first if we take the behind part here, we have 16. Okay, then we add this side, we have another 12. So 16 plus 12 instead of 16 plus 16. Then after that, this side will be another extra of 9. So 12 plus 16 plus 9 will give us just nice 37. Okay, so it doesn't matter which one, 37 to 40, it will be 3 sides. Okay, question 20. There are n children arranged in a circle, numbered from 1 to n. They play a game of passing the puzzle. The teacher calls out a magic number and then randomly pick a child from the circle to start the game. Okay, then the game is proceed on the clockwise direction. The students must pass the puzzle to the player who is away from the magic number of places. Okay, if let's say the teacher asks the students number 4 to start the game and the magic number is 2, so you have to be 4 plus 2 plus 2 plus 2 plus 2 plus 2. Okay, so round ends only when the puzzle comes back to the students who started the round. Okay, 5 rounds of the game were played with 4, 6, 7, 8 and 9 as a magic number. Then the same students start every time. Okay, so in every round there are at least one student who do not get the puzzle. What is the minimum value of? Okay, for this question, we realize that whenever we have a number, okay, for example 4, okay, we will just need 4 people, okay, so that it will go back to the original students. So 1, 2, 3, 4, it will always go back to the same person, okay, and skipping all the 3. Okay, but the question here is asking for the minimum. So for number 4, right, actually we just need 2 students. Okay, 1, 2, 3, 4, it will go back to the original students. Okay, then skipping this student over here, meaning it will be a factor of the magic number. Okay, so for 4, 6 and 8, okay, we will need at least 2 students. Okay, for 6 or 9, we will need 3 students. Okay, for 7, we will need at least 7 students. Okay, in other words, we will need at least 42 students for all the conditions to work. Okay, so the answer is B.